Hi, everyone. We're going to go over the solutions for the Thinking with Mathematical Models Investigation 4, the SP1 standard, which was on the paper. If you're listening to this for a retake, make sure that you are writing down everything for all the questions on the original quiz, and you show those to me when you come in for your retake. Number 1 says, which set of variables would have a strong correlation, and why do you think this would be a strong correlation? So we have shoe size and math grade, which doesn't seem to have any correlation at all. Math grade and number of pets, again, I can't see any way that that would have a correlation. Shoe size and height, I definitely think that that has a correlation, and it could be quite strong. And then science grade and shoe size, which again, I don't see any correlation at all. Therefore, I would pick shoe size and height because generally, the taller you are, the larger your feet. In number 2, they want to know which set of variables would have a weak correlation, which means that it does have a correlation, but it's just not very strong. And so also, why do you think this would be a weak correlation? So your choices are study time and math grade. And I do think that those have a correlation, but it would be strong. Gaming time and math grade, there might be a correlation there. Shoe size and height. Again, we talked about that on number 1, where that would be a strong correlation. And then math grade and the number of pets you have, which I can't see there being any kind of correlation there at all. So I would say gaming time and math grade would have a weak correlation. I don't think that your gaming time is going to necessarily 100% affect your math grade, but it could get in the way if there are people who spend a lot of time gaming. It could affect their grades. For number 3, it said match each correlation coefficient with the correct scatter plot. And so you have A, which is a pretty tight, strong correlation. We have B, which looks to be like quite a mess, and C, which is a little more spread out than A. Therefore, I would say the 0.5 would be the one C that's down here, a little more spread out. 0.86 would be the tighter, straighter line. That would be A. And then the 0 correlation coefficient would be this B that's kind of all messed up. In number 6, they wanted you to create a scatter plot that shows a correlation coefficient of R equals -1. And if you looked at your vocab sheet, -1 would be perfectly straight, going in a negative direction. And so they would be completely lined up. It doesn't have to be in the same spot as mine, but they would be in a perfect row. And notice it says scatter plot. So these are not connected with a line. It's just a set of points. In number 7, they asked you to create a scatter plot for the following data. One of the things that's very important when making a line plot is that you have to have a consistent scale on your line. Therefore, we have a line, and we're going to put all of the numbers, including 10, even though there's no data at 10, we're still going to put the 10 on there because we need a consistent scale. You can't just skip a number. And if you wanted to start at 7 or go to 14, that's fine as well. We had 1 mark at 8, 1 mark at 9, nothing at 10. We have a mark at 11. We have 1 at 12. And then we have 2 at 13. So again, the consistent spacing and numbering of your line, and then just placing the marks above each piece of data. Number 8 asked what was the range of the following data, and you could have given this to me in several different ways. You could have told me that it went from 8 to 13. You could have told me it went from 13 to 8. And you could have told me that the difference was 5, that there was a spread of 5. Number 9 asked us to calculate the standard deviation for the following data. And they gave you the mean already. You didn't have to figure that out, but you certainly could have added those up and divided by 6, and you would have gotten a mean of 11. And so we're going to go step by step, just like it was in the vocab sheet. And I think on one of our lab sheets, we had the step-by-steps as well. So the first thing was find the mean, and then you subtract the mean. That was finding the mean, but they already did it for you. And then you're going to subtract the mean from each data value. So you're going to do 8 minus 11, 9 minus 11, 11 minus 11, 12 minus 11, 13 minus 11, and 13 minus 11. And our values were -3, -2, 0, 1, 2, and 2. And I know some of you are a little confused because we're now going to square these numbers and they're all going to turn into a positive number. And in class, I told you if you wanted to, you could just think of this as the absolute value of what that difference was, so that we didn't kind of mess up our squaring. And some of us still squared our numbers and ended up with a negative number. But remember, if you're multiplying a negative times a negative, it gets you a positive answer. So squaring each of these differences, we get -3 squared, -2 squared, 0 squared, 1 squared, 2 squared, and 2 squared. And then we're going to add those squared values together. So -3 squared is 9, -2 squared is 4, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 2 squared is 4. When I add those all up, I get 22. Step 5, divide the sum by n minus 1, which is the number of data values minus 1. So I take 22 and I divide it by 6 minus 1, which is 5, and that gets me 4.4. And then we just have the one final step, and that is to find the square root of 4.4. When I put that in my calculator, I get it's about 2.1. I rounded it. So the square root, second, x squared button, and then type in 4.4, and you get 2.1. Number 10, very similar, except for they did not give us the mean. So we had to find the mean on this one by adding up all our values and then dividing by how many values there were. So I add 1 plus 6 plus 7 plus 8 plus 8 plus 9 plus 17, and I get 56. There are 7 pieces of data. So 56 minus 7 gives me a mean of 8. So again, the next step is subtract that mean from each data value. So 1 minus 8 is -7, 6 minus 8, -2, 7 minus 8, -1, 8 minus 8 is 0, 8 minus 8 is 0, 9 minus 8 is 1, and 17 minus 8 is 9. And then I noticed a lot of people were putting maybe 14 down for 7 squared. So if you need to, use that calculator to check those. So we're going to square each of these differences. And again, when you square any number, whether it's positive or negative, your answer will be positive. So negative 7 squared, I get 49. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 0 squared is 0. 1 squared is 1. And 9 squared is 81. Step 4 would be to add those squared values up. So I'm just going to add 49 and 4, 1, 0, 0, 1, and 81 together to get a total of 136. Next step is to divide this sum, the sum of 136, by n minus 1. How many pieces of data are there? Minus 1. So I have 136 divided by 7 minus 1. And so 136 divided by 6 is about 22.7. And I was very lenient. If we didn't round it the same way, it was fine. If you showed me that you were doing this step and you got a number close to mine, I was good with that. Again, the final step, take the square root of that number. On your calculator, that's second and x squared to get the square root symbol. Type in the 22.7. And when you hit enter, you would get about 4.8. Again, rounded. Which makes sense. 4 squared would get me 16 and 5 squared would get me 25. So 22.7 is going to be in between 4 and 5. And the last two questions have to do with our crickets and being able to count the number of chirps to find the temperature. So it says you can find the temperature in degrees Fahrenheit by counting the number of times a cricket chirps per minute and then dividing that number by 5. And then finally adding 50. So the first question they asked me was write an equation using F for temperature and C for chirps per minute. And so you have F is equal to the chirps per minute, right? Chirps per minute, then divided by 5. So C divided by 5. And then finally adding 50. So plus 50. Part B asks, what is the temperature if the cricket chirps 125 times? So they're giving me the number of chirps. I'm going to plug that in for C to find what the temperature is. That would be my F. So 125 divided by 5 plus 50. So 125 divided by 5 plus 50 is the same as 25 plus 50. And 25 plus 50 is 75 degrees Fahrenheit. So that was the whole quiz. Once you get all this written down on your original quiz and then do the problems in that Delta Math, you will be all set. Bring it in and you can do your retake. Have a great day or night, and I will see you soon.